Before we go into the equivalency and the equality of sets, the first thing we need to understand is the cardinality of sets. When we are working with equivalent and equal sets, the number of members and the types of members play a heavy role in why these sets are classified as equal or equivalent. So you guys know what cardinal numbers are, right? Yes or yes?
Yes,
if you
sir.
don't know, fine.
Yes.
Yeah,
Sir.
you know, cardinal numbers are the opposite to ordinal numbers. While ordinal numbers tell you what? What do ordinal numbers tell you? Ordinal. It comes from the word
Position.
order.
The position of the
Thank you
number.
very much. Yes, it tells you the position of the numbers, while the ordinal numbers would tell you the number of elements within a set. Now, on screen it says cardinality or cardinal number of a set is just the number of elements in the set. So the cardinality of a set has to do with the number of members or elements in the set. Here it says the cardinality of the set containing elements 2, 4, and 6 is 3, because there are just 3 elements or members in the set. It's simple, right? I don't have to spend too much time on it. Not true?
No, sir.
All right, cool. So let me jump to the next one. Now, when representing the cardinality of a set, you have to use the following symbol. And I'm going to use my spotlight to circle it. So right here. So the N, you open your brackets or braces or your parentheses, and then you place your element, the number of elements or the name of the set, within those parentheses, followed by an equal sign that will tell you the number of elements within that set. All right, So the symbol for cardinality, and it shows it below. If set A is equal to 2, 4, and 6, then the cardinality of set A is 3, because as you can see, 3 elements or members are in that set. Now let's jump to equivalent sets. Let me stay where I am and let me ask the question. When something is equivalent, what comes to mind? So when you hear about something being equivalent,
it means that something are the same or similar.
The same. And we can say the same for, I'm plugging in my laptop, give me a second. And we can say the same for the word equal. Because I'm sure if you see, say you see this. Let me go and write something on screen. What if one day I come and I ask you to solve this? What would your answer be? Or what would you do?
You would put the equal sign.
You'd put an equal sign because both sides are the same. So we can agree that the terms equal and equivalent are the same. No. I started there because I didn't want anybody to get tied up or confused as we go along. All right, I need somebody to read this for me. So let me pick on you. Khalil, could you read this for me? Because I haven't heard from you yet.
two sets that are equivalent if they have the same numbers of elements or the same cardinality.
Yeah.
And if
Yes.
if A equals 2, 4, 6 and B equals 1, 1, 3, 5, N A equals 3 and NB equals 3. A and B are equivalent sets.
All right, cool. So next time around, you don't have to say NA, you can say the cardinality of set A and the cardinality of set B. All right, so though set A and B are equivalent, you will realize that the elements in both sets are different. So set A has the elements 2, 4, 6. Set B has the elements 1, 3, 5, yet they are equivalent. Now, the equivalency of sets does not do with or is not so much concerned with the similarity of the elements, but rather the similarity of the number of elements. So those set A and B have different elements, the number of elements are the same. Whenever you're looking at the equivalency or equivalent sets, you're merely saying in sets A and B, is there in both sets, do they both have the same number of elements? No. If it was a case, no. I'm gonna write for a bit. If it was a case where, say, set, oh, geez, give me a sec. Oh, my bad. Cool. If it was a case that set A had 2, 4, 6, and set B had say 1, 2, 3, 4, would we say these two sets are equivalent?
No, sir,
Why not?
because they don't have the same numbers in each set.
Because it doesn't have the same numbers, or it doesn't have the same number of elements.
It does
Which
have
of
the same number of elements.
number of elements, because A has 3, B has 4, so they wouldn't be equivalent. So when sets are equivalent, it has to do with the number of elements in each set, whether or not they are the same. So if they both have the same number of elements, they are equivalent. But if they do not have the same number of elements, then they would not be equivalent. All right. Is that
Yes,
clear?
sir. Yes, sir.
All right, cool. Moving along to the next one, equal sets. All right, Trishan, could you read this for me, please?
Two sets are equal if they have exactly the same elements. Order doesn't matter. If A equals 2, 4, 6 and B equals 6, 4, 2, A and B are equal sets.
So when sets are equal, just as Trishan read a while ago, the elements are the same. It doesn't matter how they are ordered. Once they have the same elements, then they are equal. They are equivalent when they have the same number of elements, but they are equal when they have the same elements. Let me move to my next slide. So let me do this little example before I proceed. So if I have set Q, and set Q has circle, triangle, and square, and set R has square, circle, and triangle. These are equal because they have the same elements in them. The order doesn't matter. But if I had, instead of a triangle, I had a diamond, then the two sets would not be equal, but they would be equivalent. Equivalent on what basis? Why would they be equivalent and not equal?
But because it has a different
Have the
shape.
same amounts of elements, but different order.
Go again, repeat. You were talking, Tommy, go ahead.
As saying they have the same amounts of elements, but different orders.
So same amount of elements, but they're different. All right, cool, thank you. Shoshan, you were saying something before?
No, sir.
All right, cool. All right, so let me clear and move right along. All right. Now it says equal sets are equivalent for 6 and set B have 6 for 2. A and B are equal sets. It says the cardinality of set A and the cardinality of set B are both 3, which means they are equivalent. So it's equal when you have the same elements in each, regardless of the order. It's equivalent once you have the same number of elements. All right, everyone?
Yes, sir.
All right. Now, here is the flip side. Equivalent sets may not be equal. It says if A is equal to 2, 4, 6 and B is equal to 1, 3, 5, then set the cardinality of set A and the cardinality of set B are both 3. It says that would make set A and set B equivalent on the basis that all the elements, they have the same number of elements, but A and B are not equal sets because they do not have the same elements in each set.